2015 question 2 part A. Two cars A and B travel along two straight roads which intersect at an angle of 135 degrees. Car A is moving towards the intersection at a uniform speed of 60 kilometers per hour. Car B is moving towards the intersection at a uniform speed of 45 kilometers per hour, and it passes the intersection 2 minutes after A. In part 1, we have to find the magnitude and the direction of the velocity of B relative to A. Now, car A is just moving east with a speed of 60 kilometers per hour. Now, car B, you can see, makes an angle of 135 degrees, and that's with the negative sense of the y-axis, or that would be 45 degrees with the positive sense of the y-axis. So the velocity of car A is just going to be 60i. The velocity of car B, now because car B is moving northwest, northwest means we have a negative I and a positive j. So the velocity vector for B is going to be minus 45 cos 45 degrees I plus 45 sine 45 degrees j. And this works out as minus 45 root 2 over 2i plus 45 root 2 over 2j. Now, by definition, the velocity of B relative to A is denoted by VBA, and this just equals VB minus VA. So the VB was minus 45 root 2 over 2i plus 45 root 2 over 2j, and from that we have to subtract VA, which is 60i. So this means the velocity of B relative to A is minus 91.82i plus 31.82j. To find the magnitude, we use Pythagoras' theorem, and Pythagoras' theorem then gives a speed of 97.18 kilometers per hour. Next of all, to find the direction, we first of all find the angle. The tan of the angle is a positive j over the positive I. This is going to be 31.82 over 91.82. And then theta would be the inverse tan of that. This means the angle theta works out as 19.11 degrees. Now we're going to store this exact angle in memory A on our calculator, as we will be using this later on. So now we can write the direction. Because we've got a negative I, it means west. So the direction is west. We then make an angle of 19.11 degrees towards the north because it's a positive j. Next of all, we want to find the shortest distance between the two cars. Now, when car B gets to the intersection, car A has moved on past the intersection for a time of 2 minutes. So in that 2 minute time interval, we need to know exactly where car A is. So the distance between car A and B is going to be the speed times the time. Now the speed of car A is 60, and the time is 2 minutes, which is 2 over 60 of an hour. And that works out as 2 kilometers, which is 2,000 meters. So what this means is that when B is at the intersection, A is 2 kilometers or 2,000 meters to the right of car B. So we can represent this information on an I and J plane. So when B is at the intersection, A is 2,000 meters east of B. Now, the velocity of B relative to A, this direction here, we worked out this exact angle as 19.11 degrees, but we're going to store this, or we have stored this exact angle in memory A. Now, in order to get the shortest distance from this vector to this point, we have to go back in time. So if we go back to this point C, and then we can get the perpendicular distance from this line to the point A. If this is an angle theta, this is also your angle theta. And if this hypotenuse is 2000, the opposite is going to be 2000 sine theta. So the distance from A to C is 2000 sine theta. The distance from B to C would be 2000 cos of theta. Now the shortest distance then is the distance from A to C. So the shortest distance is the distance from A to C, and that's 2000 sine of theta. We've the angle theta stored in memory A in our calculator, so this is 2000 sine of recall A, and this works out as 654.88 meters. Part B then. A woman falling vertically by parachute in a steady downpour of rain observes that when her speed is 5 meters per second, the rain appears to make an angle of 45 degrees with the vertical. When her speed is 3 meters per second, the rain appears to make an angle of 30 degrees with the vertical. Now notice these angles are given relative to the vertical. We have to find the magnitude and direction of the velocity of the rain. So the velocity of the rain is unknown. We're just going to let that equal xi plus yj. So we've got two different scenarios here. In the first scenario, the woman is moving downwards with a speed of 5. So we can represent this using I and j notation as 0i minus 5j. So because she's moving south, it's a minus 5j. Now here, the velocity of the rain relative to the woman makes an angle of 45 degrees with the vertical. Now that would also be a 45 degrees with the horizontal. And this means that the I and j component are going to be the same in magnitude. And you can see if the direction of the rain is moving like this would be roughly southwest. So it means we're going to have a negative I and a negative j. So this means the relative velocity of the rain relative to the woman can be written just as minus ui minus uj. Now, by definition then, v or w is vr minus vw. So this means minus ui minus uj equals the velocity of the rain is the xi plus yj minus the velocity of the woman, which is 0i minus 5j. If we then equate the coefficients of the i's on both sides, on the left-hand side in front of the I, we've got minus u. On the right-hand side, we've just got x. There is no I term here. And similarly, if we equate the coefficients of the j's, minus u is y minus 5, which is a y plus 5. So you can see with these two equations, the left-hand sides are the same, which means we can equate the two right-hand sides. So this means x equals y plus 5. And we can also write this as x minus y equals a plus 5. I'm going to label this as equation number 1. So we formulated this equation using the first scenario. Now, the second scenario then is when her speed is 3 meters per second. Now, as a velocity, this will be minus 3j. So the velocity of the woman is 0i minus 3j. Now, the velocity of the rain relative to the woman. Now, we're told that the rain makes an angle of 30 degrees relative to the vertical. That means it's going to make an angle of 60 relative to the horizontal. If the relative speed is v, the horizontal component is v cos 60, and the vertical component is v sine 60. And again, this direction is roughly southwest, which means we're going to have a negative I and a negative j. So this means the velocity of the rain relative to the woman can be written as minus v cos 60i minus v sine 60j. So this means v or w works out as minus v over 2i minus root 3v over 2j. And again, by definition, v or w is vr minus vw. So this means then on the left-hand side, we've got minus v over 2i minus root 3v over 2j. And then on the right-hand side, the velocity of the rain, again, is xi plus yj minus, and the velocity of the woman is 0i minus 3j. Once again, equating the coefficients of the i's, we've got minus v over 2 equals x. And then equating the coefficients of the j's, minus root 3v over 2 is going to equal y plus 3. Now, what we're going to do is try and match up these left-hand sides. If we multiply the top here by root 3, so we're going to multiply both sides by root 3. And you get minus root 3v over 2 equals root 3x. So this left-hand side is now the same as this left-hand side, which means we can equate the two right-hand sides. So this means root 3x equals y plus 3. And again, bringing the y over, we can formulate this equation, root 3x minus y equals 3. So now we have a system of two equations with two unknowns, which we can solve simultaneously. So if we just add equation 1 and equation 2 together, the y's will cancel. And with the x's then, if you factorize out the x, you're left at 1 minus root 3. And then on the right hand side, 5 minus 3 is 2. And this means x equals 2 all over 1 minus root 3. Now if you put that into your calculator simplifies it as minus 1 minus root 3. If we put this value for x back into equation number 1, so we've got y equals x minus 5. This means minus 1 minus root 3 minus 5, and this works out then as minus 6 minus root 3. So we now have a value for x and a value for y. So this means the velocity of the rain in terms of i's and j's can be written as minus 1 minus root 3i plus and minus 6 minus root 3j. To get the magnitude, we have to use Pythagoras' theorem. And using Pythagoras' theorem, the magnitude of the velocity, which is the speed of the rain, works out as 8.2 meters per second. Finally, to get the direction, we first of all get the angle. The tan of theta is the positive j over the positive I. The positive j is going to change this to a plus 6 plus root 3, and the positive I is going to be 1 plus root 3. And then this means theta will be the inverse tan of that, and that gives an angle of 70.54 degrees. So this means the direction is west because we've got a negative I, and then the angle is 70.54 degrees towards the south because we have a negative j.